All right, the last part of chapter 8 is going to kind of tie everything together when we talk about exponential functions. So by the end of this lesson, you should be able to evaluate exponential functions and to graph them. So think back to when we first started chapter 8, we learned what an exponential function is. And it always takes on this form, y equals a times b to the x power. A is a constant, and b has to be greater than 0, not equal to 1, and is a real number. So they gave a couple examples. Remember, this is always our y-intercept, and this is always our growth factor. So if you are asked to evaluate an exponential function for a domain of -2, 0, and 3, evaluate means to find a value, or just a number. And the domain, remember, is our inputs. So we're being asked to find outputs. So if I plug in -2, if I plug in 0, or if I plug in 3, what do I get out? So we can set up a nice little table. Remember, we tend to call our inputs or our domain the x values, so we're going to plug in -2, 0, and 3. And then we just have to do some math. So when we plug this in, we get 4 to the -2nd power. Now remember, that means that we have 1 over 4 to the +2nd power. We're dividing by 4 twice, and we get 1/16. And if we plug in 0, this one's a little easier. Remember, anything to the 0 power is just 1. And then to the 3rd power. Remember, that means 4 times 4 times 4. So 4 times 4 is 16. If you multiply by 4 again, you get 64. So my range for those domain values are 1/16, 1, and 64. Let's skip the one in the middle and do the last one. So again, I'm still going to plug in the same things because they told me to plug in -2, 0, and 3. So when I plug in -2 for this first one here, we need to think about PEMDAS. So PEMDAS, remember, says we got to do exponents first. So this is really 1 over 3 squared. Oops, it's supposed to be multiplication. Which turns into 1/9, which ends up being -2/9. 0 is always easy to plug in. 3 to the 0 is just 1, so you end up with -2 times 1, which is -2. And then finally 3. Got to do exponents first, so 3 cubed is 3 times 3, which is 9, times 3 again, which is 27. And then we got to multiply that by -2, so we end up with -54. So our range for this one is -2/9, -2, -54. So now let's talk about their graphs. I know that your paper isn't colored, so I would take a second and use some colored pencils or highlighters or something and make sure that you can identify each one of these. So this first one over here is 2 to the x power. And then the next one is 3 to the x power. The green one is 4 to the x power. And then finally, this purple one here is 5 to the x power. So if you look, the thing that's changing here is our growth factor. Remember, we have the equation y equals a times b to the x. For all of these, the a value is just 1. And if you look, that's our starting point. That's where it crosses the y-axis. That's our y-intercept. And for all of these, a equals 1, so they all cross right here. And then the b is how quickly it grows. So when you're looking at this, the red one is doubling every time. So it's not growing as quickly as the 5 to the x power. That is 5 timesing every single time. So you can tell when it starts down small like this, there's not much of a difference. This one reaches 2 at about 2, and this one reaches 2 at about, I don't know, a half. But as they continue to go, it makes a huge difference. Like right up here at the 8. So if we look up here where our graph like disappears, the purple one reaches 8 about right here, which this is 1, so a little more than 1. Where the 2, it takes it all the way over here, which is at 3 to reach that. And then the gap just keeps getting bigger and bigger the quicker that it climbs. So bigger numbers here means that it increases quicker. Where when we're looking at decay, all of these still have an a value of 1. So if you look, they all cross right here at 1. A decay value of 1/2 means that half of it is going away every single time. And again, make sure that you can find each of these. This is 1/2 to the x. The blue one is next, that's 1/3 to the x. The green one should match up here, that's 1/4 to the x. And then finally the purple one is 1/5 to the x. So when you're looking at this, the things that decrease quicker are the things with smaller numbers. So like 1/5, again, decreases the quickest. That's because only 1/5 of whatever you have is left every single time. So if you started off with 100 of something and you cut it in half, so the red one would be at 50 after 1 decrease. Where if you're talking about the purple function, you take 1/5 of that, suddenly you're at 20. And then the next one of this would be 25. And again, you're taking 1/5 of this, so it would only be 4. So you can see that the bigger you get, this is like the 1/5 to the x, and this is the 1/2. The smaller the fraction that you have, the quicker that it decreases. And that's why the purple one has a much steeper slope than the red one. And then let's change the last thing that we haven't changed. So all of these keep the 2 to the x. So all of these are doubling. The thing that changes is their y-intercept this time around. So this is 1, and then 2, 3, 4. So if you look, all of these graphs have the exact same curve to them. The thing that changes is where they cross. So the purple one comes up and crosses here at 4. That's where that comes from. The green one comes up and crosses right there at 3. We can see the blue one crossing at 2. And then finally the red one crossed where all of the other ones we've looked at today have crossed at the 1. So you should be able to take all of this information and turn it into a problem like this. What does the following function look like? What's the a value? What is the b value? So when we take a look at this, the first thing I want you to notice is the b value. Is this exponential growth or exponential decay? So the b value is 3. Because it's bigger than 1, that means we have growth. So our graph should shoot up. The a value, remember, tells us the y-intercept. So the a value is 4. That's our y-intercept. So to make the rest of our points, what we need to do is just plug stuff into this. They told us what x values to plug in. So I'm going to plug in -1. I'm going to plug in 0. Plug in 1, 2, and 3. So this first one, remember this means that you have 4 times 1/3, which when you multiply together you get 4/3. So if I go to graph that, I'm going to go over 1, up about 1 1/3. So there's my first point. My next one, anything to the 0 power, remember, is just 1, so I get 4. 1, 2, 3, 4, which is good because remember we said that was our y-intercept, and we can clearly see that's where it crosses the y-axis. This next one we'll do 4 times 3, which will give us 12. So over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we can see anything else we plug in here is going to be off the graph. So let's go backwards one more and make one more point. So if I plug in -2, remember that that is 1 over 3 squared, which is 1/9. And you end up with 4/9, which is about 0.44, so somewhere about right here. Now one thing that we haven't talked about with exponential functions is every exponential function has something called an asymptote, which is a line that the graph doesn't cross. And for the exponential functions we're going to talk about in this class, it's this line here. It's the x-axis. Your exponential function will never cross this line. It gets really, really close to the line as x gets bigger, but it never crosses it. So our graph, we can see, shoots up like this, and when it comes down, it doesn't cross that blue line. It just gets really, really close to the blue line and kind of flattens out. And you can see that from all of these that we graphed here. See how they get really close to this? They never cross that x-axis. See here again, they get really close. And there, one more time, they all kind of come together and get really close. So you don't need to know the word asymptote. You don't need to ever tell me what it means, but just know that these never cross the x-axis. So you should be able to evaluate and graph exponential functions. This is very similar to the one that we did here. Hopefully you'll notice the little change and see what that does to your table and to your graph. Write down any questions you have. We can go over them tomorrow before we start our review. Have a good night.